Hi everyone, welcome to Tuteetute. In previous session we discussed about introduction of electrical drives. There we discussed about the classification of electrical drives also. That means the first classification we discussed is based on the supply given to the drive system. Those are AC or DC. Based on the supply we divided into AC drives and DC drives. Today's our session is about DC drives. In DC drives we are going to discuss about different basics of converters and motor parameters and speed control methods of different DC motors. At last starting and braking with the help of power electronic converters. Let's start the session. Okay, this is the simple schematic of a given DC drive. Okay, the input for a DC drive, in DC drive we are employing a DC motor. So the first thing what we need to see here is we are employing a DC motor as a prime mover. Okay, the prime mover of a given drive is a DC motor, but the available supply is AC. This is the source. Available supply is AC. With the help of modulator, power modulator or power converter, we converted AC into DC and we are fed to the given DC motor. Okay, so given DC motor, and one more converter we are using in field. This power modulator is for field control. Okay, this is for field control. Okay, so we are using two power modulators. One is for the motor input and one more is for the field control, for controlling the field of the given DC motor. Okay, the feed what are the output of a given DC motor are torque and speed. With the help of sensors, we are using a tacho generator. We are going to measure the speed of the given DC motor and we will send to the control unit. Okay, we are sending the speed parameter to the control unit and the operator is given some reference speed. That means the desired speed of the operator is the speed reference. Let's take it as NREF. Okay, this is the NREF. So this control unit will simulate the reference speed given by the operator and the speed calculated from the motor, so that it will generate the, in our case it is a converter, so it will generate the firing pulse. Okay, based on the calculations of reference speed and actual speed of a given motor, the control unit is generated the firing pulse, so that the power modulator will control the output voltage or input voltage of a motor, output voltage of a converter or input voltage to the motor, so that we will achieve the desired speed condition by the operator. Okay, I am going to summarize the things. DC drive is nothing but the main prime mover we are going to use here is a DC motor. The supply may be a AC supply or DC supply. The AC supply, if you consider, it may be a single phase or a three phase supply. Okay, so by using a power modulator, we are modulating the given AC source to a DC source and we are running the load. Okay, we are running the load. With the help of sensors, we are measured the speed of a given motor and the operator is going to give some reference speed, that is NERF. So the control unit will simulate these two speeds and it will generate the required firing pulse, so that our motor is going to be run at a desired speed of the operator. This is about the basic schematic under the DC drives. If you observe in the schematic of a DC drives, what are the different major equipments are coming? First one is power modulator. Second one is motor. Okay, the basic apparatus you are using in our DC drive are power modulator and motors. Based on the given supply, either it is AC or DC, we are going to select the power modulator for our suitable machine. Okay, next motors based on the load. We have already discussed different types of loads in a previous session. Based on the load requirement of the load, we are going to choose the DC motor here. We are going to choose the DC motor. Okay, is it clear? Okay, we'll go to the basics of converters. Okay, for I am going to confine to the theory topic and confine to the DC drives only. Okay, basics of converters means here we are having two supplies, AC and DC supply. AC and DC supply. But the motor is this is source. Let's take it as source. Sources are AC and DC, and our motor is DC motor. Our motor is DC motor. Since I am discussing about DC drives, my primary is a DC motor. But the input for a DC drive may be a AC supply or DC supply. Okay, if you consider a AC supply, there are two types: single phase AC supply or three phase AC supply. Okay, three phase AC supply. In single phase, again there are three types are there. One is half controlled, second half controlled, second one is semi controlled or semi converter, or you can say semi controlled, and third one is full controlled. We are going to use full controlled converters. What converter is going to do? Converter is going to do is conversion of AC to DC supply. Desired AC to DC supply. Similarly, three phase also there are three types. I am going to write in a short form, that is half controlled HC, semi controlled HC, and full controlled FC. Okay, for suppose the available source for a given DC drive is a AC supply, then which type of power modulator we need to use are, if it is a single phase supply, we are going to choose either half controlled, semi controlled, or full controlled based on the load requirement. That means we are based on the power rating of the load. Okay, similarly three phase supply, if it is three phase supply, the classification of power modulators are similar to single phase. Okay, what this power modulator do in our case is, it is going to convert the AC into DC. For suppose if the source is a DC, for our DC drive, then what type of power modulators we are going to use? Choppers. What choppers will do? It will convert fixed DC to variable DC. Okay, so for suppose for our DC drive, if the available supply is a DC supply, either from the battery source or some other means, we have a fixed DC source. So with the help of choppers, we are converting this to fixed DC to variable DC based on the requirement of the motor, to meet the desired load conditions. Okay, so these are the different basic type of converters we are going to use for the DC drives. Next, coming to basics of DC motor. Okay, before going to the classification of DC motors, first we will see different electrical parameters related to the DC motor. First thing, back EMF. First thing is back EMF. EB is equal to pi ZNP by 60A. Pi ZNP by 60A, where Z and P and A are constants. Where A and Z and P are constants. If A and G are constants, that means during construction time these parameters are going to be fixed. Then so we are discussing about the operating condition of a DC motor. So we are treating all other parameters are constant. Then EB is directly proportional to pi n. EB is directly proportional to pi n. From this you can write our speed is directly proportional to EB by pi. EB by pi. This is important relation we are going to use frequently for our analysis of DC drives. Okay, this is back EMF. Second one is one more equation. General equation of a DC motor is V is equal to EB plus IARA. Okay, this terminal voltage, let's take it as a terminal voltage. General equation for a DC motor is Vt is equal to EB plus IARA. Okay, from this you can write IA is equal to, V minus EB by RA. V minus EB by RA. This is important for our analysis. Second one is, we know that mechanical power developed is equal to 2 pi nt by 60A. Mechanical power developed is given as 2 pi nt by 60A. Here n is the speed of the motor, T is the torque developed by the motor. From this, and we can also write it as EB into IA. This can also written as EB into IA. Okay, from this equation you can write n into T. Other parameters are constant. N into T is equal to, you can substitute this equation here, pi z np by 60A into IA. Okay, this n and this n you can get cancelled, and torque is you can write it as directly proportional to flux and armature current. This is important. Okay, whatever I highlighted in the boxes, these formulas we are going to use for the analysis of DC drives in our upcoming sessions. Is it clear? So I taken just basic equations. From that I consider the different relations. Okay, different relations for our analysis of DC drives. Coming to different types of DC motors. We already studied in the electrical machines about DC motors. That means based on the connection of field winding, we are classified in DC motors as like this. These are classification based on connection of field winding. This classification is based on connection of field winding. Okay, based on the connection of field winding, we classified the DC motors into first two types, separately excited and self-excited. Next, self-excited. Separately excited means the field winding is separately excited by a different DC source, whereas self-excited means the field winding is excited by the motor itself. Whatever in initial condition, some residual magnetism we will develop with the process of field flashing. After that we will connect to the motor. See, because of this residual magnetism, the motor will start developing some small torque. With that, the motor will get starts. Once the motor started, some current, with the help of this torque development and currents, the field winding will get excited. Okay, so this self-excited again classified into three types, mainly three types: series motor, shunt wound motor, and compound motor. Why you are calling like this means the field winding based on the, this is the field winding, based on the field winding connection. Based on the field winding connection, we classified the self-excited motors into different types. First one is series motor. In series motor, the field is connected in series with the armature. Next, shunt motor. Shunt motor, the field is connected in shunt to the armature. Compound motor. The compound motor means it is having two windings, both series winding and shunt windings. If the Again, compound motor can be classified into two types. If the shunt field winding, this classification is based on the shunt field winding connection. Shunt field winding connection. Based on the shunt field winding connection, this compound motors again classified into two types, long shunt and short shunt. Okay, we are going to confine our discussion for separately excited motors and series and shunt. Okay, most of the drives are based on this only. Compound motor and shunt motor, compound and shunt having shunt motor having almost same speed torque characteristics, almost same speed torque characteristics. Okay, so same speed torque characteristics, but wherever high running torque, what I mean to say, wherever high running torque is there demanded by the loads, that time we are going for the compound motors. Normally we will use the shunt motors only. So for our simple discussion, we will consider separately excited and separately excited motor and series motor and shunt motor with different techniques, how we are going to control the speed and how we are going to apply the brakings and how we are going to start the DC drives. We will explain simply with the help of separately excited and series motors. Okay, this is about classification of DC motor. Coming to starting methods of DC motor. Till now what we discussed, basic schematic of DC drive and different basics of converters and basics of DC motor and classification of the DC motor. Now in this session we are going to discuss about how we are going to start the DC motor. So we already know the equation IA is equal to V minus EV by RA. Okay, in this where RA is armature resistance far less than 1. Okay, in general it is made up of copper wires. Because of copper wire is a good conductor of electricity, the resistance offered by the copper wire is very small. This is the first consideration we need to see. Second consideration is during starting, at the time of starting, you can say at the time of starting speed is equal to 0. At the time of starting, speed equal to 0. Okay, we know the relation EB is equal to pi ZNP by 60A. In this speed is 0 means EB is going to be 0. Okay, so we are going to substitute back to our equation. IA is at the time of starting armature current is equal to V minus 0 by RA. As RA is very low, RA is very low, as RA is very low because of the armature winding is made up of copper, the resistance is very low. The starting current is very high. Okay, so at the time of starting itself, the motor is experiencing high starting current. These starting currents may be 4 to 5 times, sometimes 10 times also, more than 10 times of the rated current. Okay, because of this high starting current, the motor may get damaged. Okay, the motor may get damaged. In order to protect the motor, we are going to apply the starting methods for our DC motor. Okay, starting methods we are going to employ. What are the different methods we are going to employ? So first we will see what is the problem we are facing. The problem is the main problem we are facing here is RA is very low. So because of this only high starting current is coming. If we are able to improve the armature resistance by connecting a external rheostat, okay, if we are able to change this if we are able to increase net resistance of armature, if you are able to increase the net resistance of the armature, then armature current is going to be decreased, so that our motor will operate in a safe current. Motor can operate at a safe current. Okay, for that what we are going to do, we are going to insert a external resistance RA plus RE. Okay, by external resistance we are inserting, by that we are reducing the current. Net resistance of armature. Okay, so what we saw what is the problem while starting a DC motor is it is drawing high starting current. So in order to minimize the starting current, we are going to increase the resistance of the armature by means of connecting external resistance to the armature winding. So by that the starting current is going to come down, by that our motor can operate in a safe current. Okay, so based on the external resistance inclusion, we are classified the starting methods into three types: 3-point starter, 3-point, 4-point, and 2-point. Okay, 2-point starters. Starter is a device. Okay, starter is a device which is going to reduce the starting current during starting time and normalizing the circuit of the motor during running condition. One more thing is, if you are continuing this one during running condition, what will happen? During running condition, if it is continuous during running condition, I square during running condition, I square R losses is going to be increased. If you are inserting external resistance continuously during running condition, the I square R loss going to be increased. That means copper losses are going to be very high. So what we need to understand from this session is we need the external resistance only at the starting time, and we need to remove the external resistance during running condition, so that we can reduce the starting current, and we can improve the running performance of the given motor. For that we are using a device. That device is called starter. Starter is nothing but a device which is going to reduce the starting current at the time of starting and improving the running condition of a motor by means of applying some electrical apparatus. This apparatus is called starter. These starters are classified into three types: 2-point, 4-point, and 2-point starters. In all these starters, the principle is same. The basic principle is inclusion of external resistance during starting. So the principle is same, but each method is having some drawbacks that are going to overcome by next methods. Okay. First method is 3-point starter. Okay, this is our motor. This is our motor. This is our motor. What our motor is doing? Our motor is having armature. This is armature, and our motor is having armature and field. Okay, so we need to we need to give the supply to the armature and field such that external resistance is going to be included in during starting and removed during running condition. Okay, during running condition. For that, here we are going to employing a plunger. Let's take it as a plunger. This is plunger, and if you observe the name of the starter is 3-point starter. Here there are 3 points are there. One is L, line, and F is field, A is armature, Okay, so the 3-point starter is nothing but in this starter we are going to access 3 points from the given motor. Okay, to connect the starter we can access 3 points from the given motor. Okay, so those points are line, field and armature. We need to connect these 3 points such that this external resistance, this is external resistance Re, going to come into picture during starting condition, and we need to nullify this external resistance during running condition. For that, what we are going to use? We are going to use the plunger. With the help of plunger, we are going to move the plunger slowly in this direction. Slowly we are moving the plunger slowly towards the 5, from 1 to 5, So whenever this plunger is connected at 1, the total resistance included is at position 1, total resistance included, external resistance is R1 plus R2 plus R3 plus R4. Okay, whenever the plunger is at position 1, the total resistance included in the armature circuit is R1 plus R2 plus R3 plus R4. So gradually we are moving the plunger from 1 to 5, so that by that time the EB is developed. So when EB is developed, first speed developed and then EB will develop. EB will develop means armature starting current is going to be reduced at this running condition. So we need to move the plunger such that the external resistance should be included in the starting and we need to be nullified during the running condition. By that we can operate our motor very safely. We will discuss about different operators is there in our 3-point starter. First one is OLC. OLC means overload release coil. What it will do means it is having some settings. That means for suppose 2 times or 3 times of the rated current. Okay, the safe current can carry by the motor. Okay, if the current through the overload coil is more than this setting, then this motor will operate, this OLC will act as an electromagnet and this plunger is going to be attracted. This plunger is going to be attracted. This plunger is going to be attracted when I is greater than 2 times of I rated. I take an example only, not exactly 2 times. Sometimes it may be 2 to 3 times. For safe operation of our motor, this overload coil is designed such that it can allow only the current up to 2 to 3 times into the motor. If it is more than this OLC act as an electromagnet and this plunger will get attracted. Whenever plunger is attracted means that supply is going to be tripped off. Okay, so the supply for NVC is going to be tripped. Okay, so what overload coil is going to do? Whenever high current flows it will trip the NVC, no voltage. Here NVC is nothing but no voltage coil. Okay, what is mean by NVC means no voltage coil. What is the purpose of NVC in our circuit is our plunger is moving slowly towards this position. After that it need to be withstand at this run position only. It should not come back. Okay, we are using a spring mechanism here. This spring is going to be expanded during this process. Spring is going to be expanded. So some force is acting on this plunger. So we need to hold this plunger at run position means we need some energy to hold at run position. So NVC develops, what I can say, NVC develops energy to hold at run position against spring. Okay, what NVC is going to do, it is going to develop some magnetic energy, and that magnetic energy is withholding the plunger at run position against the spring. If there is no supply to the NVC means the magnetic energy is going to be zero. So that plunger will come back to off position due to spring. So whenever OLC is operated, NVC dropped, and due to spring force, the plunger will come to off position. Plunger comes to off position. Okay, so what is the purpose of OLC is to protect our motor from high currents. How it will protect? Whenever high current flows, it will generate the high magnetic energy and it will attract the plunger, so that NVC is going to be deactivated from the de-energized. So that NVC is going to be de-energized. Plunger attracted and this going to NVC de-energized. Whenever NVC is de-energized, the plunger will come back to the off position, so that the motor is cut off from the supply. So we have protected the motor. The purpose of NVC is we need the external resistance only during starting. We know during running condition external resistance is not required. So in order to apply this condition, we employed some mechanism here. One is spring and one is NVC. During starting, what will happen? This plunger is moving slowly from 1 to 5. During this process, some spring energy is going to be acted on that, and in order to hold at run position, this NVC need to develop some magnetic energy so that it can withhold at run position. So in order to withhold the plunger at run position, we are going to use the NVC coil. In order to protect the motor from overcurrent, we are going to use the OLC coil. But if you see here, one small drawback is there. The drawback of 3-point starter is during flux control method, IF is going to be reduced. If IF reduced, NVC will drop. NVC may drop. Drop means de-energized. NVC get de-energized and plunger come to off. Plunger comes to off position. Plunger comes to off position. Okay. So what is the drawback of 3-point starter is whenever this is the current IF. Let's take it is the current IF. Okay. This is the current IF. When you during flux control method, we are going to reduce the IF. When IF is reduced, the energy to the when IF is reduced, the current flowing through NVC is going to be reduced. Whenever current is reduced, the MMF, that means it is acting as an electromagnet. Whenever current flowing through the electromagnet is reduced, it will de-energized. When it is de-energized, this plunger may come to off position. This operation is unwanted. Okay, what we are doing? We are doing the speed control technique, but during that method, it is all of a sudden motor is getting shut down. This operation is unwanted. That's why this is the drawback of 3-point starter. So 3-point starter drawback is during flux control method of speed control of during speed control method of DC motor by flux control method, the NVC is going to be de-energized and the plunger is going to the off position. Okay. This drawback is going to be overcome in this method, this 4-point starter. How we are going to overcome? This NVC is separately energized through the resistor. Through the resistor, this point, one more extra point we are included. That's why it is called 4-point starter. So the field winding is separated and NVC energization process is separated. So by this we overcome the drawback of 3-point starter, so that we can operate our motor, we can control our motor by using flux control method very efficiently. So the 3-point starter method and 4-point starter method, what we discussed till now, this can be employed for shunt and compound motors only. Okay, we can't employ this method for series motor. Okay, we can't employ this method for series motor. For that, what we are going to use for employing starting techniques for a DC series motor, we are going to use the 2-point starter. We are going to use the 2-point starter. The principle is same only, but operationally different. Okay, principle is same. Initially, the starting resistance will come at position 1, and slowly it will move to up to 5. And this is the holding coil or NVC coil. It will hold the plunger. It will hold the plunger. It will hold the plunger. It will hold the plunger, so that that starting resistance is going to be nullified under running condition. But during starting condition, the from 1 to 5 resistance is, so during starting condition, what will happen? R starting will be R1 plus R2 plus R3 plus R4 plus R5. Let's take R5. This is the starting resistance. We are going to insert into our armature RA plus RST. This is the net resistance at the time of starting. So slowly we are moving the plunger up to the 5. With the help of NVC, we are holding at run position. This starter is we are going to employ for series motor.